Now, building services include electrical services, which means energy supply and distribution, lighting, plumbing, which includes water supply, drainage and plumbing, sewage disposal, fire safety, which includes detection and protection by firefighting and timely egress, HVAC, which is heating, ventilation and air conditioning, escalators and lifts, security and alarm systems, building management systems, and so on. Some of the specialized building services required specially for hospitals would also include systems for bacteria and humidity control, emergency power, specialist gas distribution, radiology labs with special provisions, operation theatres, and so on. In a hospital, the most important factor is the safety of patients. This includes general safety, safety of the patients who are not mobile or are on life support, safety in case of fire, safety from the point of health and hygiene, avoiding cross-contamination at every cost. Ease of access and egress for patients is also very important. The hospitals and their services are designed as per NABH guidelines and the other relevant codes. When it comes to integration of the services within a structure, it is useful to look at the services not only in isolation, but in the context of the spaces they occupy in the building. As a designer, planner, and architect, it is important to know where and how various components of the services are incorporated in the building. Accordingly, the required spaces are provided in the building complex by the architect for the services. First, we shall discuss the electrical system. The major categories of the electrical system are supply, distribution, and lighting. For electrical system designs too, the design parameters are set in accordance with the codes. These are the minimum requirements that must be met. The electrical system works like this. Electrical supply to the campus would be in high voltage supply to the tune of 11, 33 or 66 kV. The main supply to the site is by HT cables. At the gate or at a nearby easily accessible location, the meter is located. From there, it goes to the substation, which is also best located at the periphery. The substation houses the HT panel and the transformer, which converts the power from high voltage to low voltage that can be used, for example, 1100 by 415 or 33 by 415 as per the connection. Electricity is distributed and managed to the LT panel room in the campus. So the main components of an electrical system can be seen in this diagram. The components on the left side indicate the high side, like the transformer, HT panels, generator, etc. And the ones on the right side show low side of the electrical components like the LT panels, distribution boards, internal wiring, etc. Lighting fixtures and sensors are also a part of this. Now, in order to make a green building and to save electricity, lights controlled by occupancy sensors are used. The transformer room may be located in the basement provided there is earth below. It is not acceptable to provide another level of basement below it. It is possible to position it on the ground level, but again, it must be directly on the ground and no building or basement may be below it. Earthing is required for transformer room. Now, the LT room may be in the basement and requires a double height. The electrical room houses LT panels and it is the main power supply center of the building. From LT panels, electricity is supplied to the whole building through cables. These cables have a relatively large diameter and are many in numbers. So for the purpose of maintenance, they are not embedded in the civil works like we do in normal buildings. Either they are laid on cable trays, suspended from the ceiling, or are clamped to the ceiling. The electricity is distributed to the floor panels located at each floor through vertical shafts and then sub-distributed to each area. The meters for monitoring electrical consumption in each area may be provided on each floor panel or in the LT panel itself. All critical areas have their own individual floor panel for electrical and their individual uninterrupted power supply or UPS, which is connected to a centralized UPS. Power backup for all essential services have to be provided. Generators are needed to provide a power backup. Due to the critical nature of life-saving equipment used in a hospital, the automated power resumption time has to be minimal and should not exceed a few seconds. DG room or the diesel generator room may be located in the basement, provided that there is no building immediately above it and no other building is located above it. It needs acoustic provisions due to vibrations. We use dense pads and isolated springs to absorb vibrations and sound. Its exhaust system should be independent. Fumes are exhausted to the terrace via DG flue pipes. In the diagram here, we can see the generator being fed by the diesel pipes, the flue pipes for exhaust and its sink panel. Fire safety provisions for DG rooms are to be made adequately. If people remember the tragic fire of Upar cinema, which consumed many lives, is believed to have started with the DG. Now the DG will have its own DG sync panel, means DG synchronization panel. The power from DG is collected at this panel and distributed to each area as per requirement. So it is used for sorting the current before distribution. Unlike regular buildings, in a hospital building, The conduits are not embedded in the civil work to ensure easy accessibility for maintenance. Cables are laid on cable trays which come under the ceiling and may or may not be covered by a false ceiling. If the basements